Once the filaments come out of the bath, a machine called a filament winder wraps them around the rotating mandrel. The speed of rotation in relation to the speed of the winder is critical because it dictates the angle of the fibers. The lower the angle, the more that part of the pole will be able to withstand the wind and provide constant, stable lighting. When a pole bends in the wind, the light appears to flicker. The number of filament layers depends on the design of each specific pole, and that's determined by a couple of factors. First, the type of light fixture the pole will hold. The bigger the fixture, the stiffer the pole has to be. The other factor is wind. The windier the location, the stronger the pole has to be. Once the winding's done, the mandrel moves on to the curing station. They pump pressurized steam into the hollow inside of the mandrel. The heat kickstarts the hardener and the epoxy resin. This solidifies the resin and cures it. The mandrel rotates so that the pole cures evenly. Curing time depends on the length of the pole and how many filaments it's made of. To help extract the pole, they pump cold water through the mandrel. This makes the steel mandrel contract, loosening the pole. Remember how workers lubricated the surface of the mandrel before winding the filaments? Because of that, the pole just slides off. The pole now moves on to the finishing stages. First, an automated sander works the surface. The customer can order from a choice of surface textures, from smooth to rough. Sanding takes just a few minutes. Now a saw makes a neat cut at the top of the pole where the metal tenon will go. A tenon is the component that'll hold the light fixture to the pole. This particular model has an arched mounting arm. The composite has cooled a bit since curing, so they reheat it to make it flexible. After a bending machine makes the curve, they spray cold water inside to cool the material. This registers the curve in the resin's memory, setting the bent shape. Now they cut out the hand hole, the opening through which the electrician will connect the underground wire to the fixture wiring. Workers then spray the pole with urethane paint. The paint acts like sunscreen, protecting the composite from damaging ultraviolet rays. This grommet hole will connect to the underground pipe that contains the electrical wires. After installing a cover over the handhole, it's time to assemble the parts. The underground pipe to the pole, and the pole to the tenon and light fixture. Many products have rounded components made of solid hardwood. Often the companies that make these products hire factories that specialize in wood bending to prepare these components for them. Bending wood may sound simple, but it isn't. It takes a lot of preparation and skill to bend wood without cracking it. The best type of wood to bend is hardwood. Its fibers react better to heat and moisture than softwood fibers do and therefore curve nicely. If you bend softwood, it wrinkles. The wood first goes into an outdoor dryer to bring its humidity level down to between 15 and 20%. This prevents the wood from expanding and contracting after it's bent. This air drying process takes up to a week. Once the wood is dry, a powerful trimmer saws the pieces to the required length, an edger to the required width. that the wood pieces are the right dimensions, they go into what's called a steaming box. This superficially rehumidifies them so that they become somewhat flexible. This takes from 10 to 45 minutes depending on the type of wood and its thickness. This humidity will later evaporate out of the wood. Now the pieces go into a press sandwiched between two forms in the shape of the curve to be made. The press applies both pressure and heat. Pressure to bend the wood. Heat generated by a high-voltage electric current to cure it, setting the new shape. How long the pieces stay in the press depends again on the species and dimensions. Generally, it takes from 20 minutes to an hour. Making this particular type of curve is called crown bending. Workers measure each piece against the template to ensure the curve is just right. The factory uses the same process to bend these pieces into a different shape. It's critical to use just the right amount of heat and pressure. Too high a temperature would burn the wood. Too much force would crack it. These straight pieces of wood will become the rounded backs of Windsor-style chairs, which is why this type of bending is called Windsor bending. Workers humidify the wood in the steaming box, but will shape the pieces using a pressure-only process. They mount what's called a bending mold onto a hydraulic press. This machine uses just pressure to bend the wood around the mold. No heat this time to immediately set the shape. Instead, once the press curves the pieces, workers hook up a chain to temporarily hold the shape.